Okay, guys, I'm a series of videos here to help you through the dune data analysis, which is a little bit complicated. So I'm preparing these to help you. So you've been given a basically raw data file. It's actually not raw data. It was actually sifted and cleaned up. There were probably problems by multiple students populating this, but for instance, they might have put in like dead wood, and we're not interested in dead wood or bare sand. We're not interested in bare sand. We're just interested in the species diversity of each plot. And let's just sort of take a quick look at this data. How's it set up? We've got species here, and in this row here, these are not species. These are transect locations. Cleaning it up. Okay, so these are meters along transect. So we'll look through here, and then in here, if you recall, what we were reporting were a cover class, not a percent cover, but a cover class. We just decided to divide cover classes up from 0 to 9, or 10, I guess, would be a possibility, 100% cover. And if you look at the first couple of transects, these are like 1 meter along a transect. There would be a 1 square meter plot. At 2 meters and then at 5 meters, there were plots on different transects. These are all the different transects lumped together into one data file. And you'll notice these first ones are empty. There were no plants in there. And if I recall, where we started those transects was actually on the beach. So it just turns out that some of those transects had no vegetation in them whatsoever. And then as we got to 6 meters, 8 meters, 10 meters, we started seeing a lot of Ammophila arenaria, European beach grass. So I'm looking at this just to make sure, hey, do what we see here make sense? Because sometimes it doesn't. And then that should alert you to the fact that you should, like ask some questions. And is there a problem with transcribing stuff into the spreadsheet? As we move along the plots, we're starting to see more diversity, which is to be expected. And another thing I notice as we come along is that it keeps going up to 75. The transects are 75 meters long. And in fact, there was a quadrat at 75 meters, which is cool. They were randomly selected, and we randomly got 75 in there. And then it jumps back to 10. That just means whoever was entering the data, I don't know, they're ordered at some point, and then they stopped being ordered, and so nothing necessarily wrong with that. If we need to order these later on, we can. In fact, we will, and so that's fine. One of the reasons I point this out is because I was with some students who went all the way to the end, and so I went like up, down to 6 and up to 73, and we actually wondered if this was a bad entry, that this 6 should have been a 66 or what. And if indeed all of these have been ordered and this is the one out of order, that would be kind of a flag that something is wrong. But then I noticed later on that no, there's multiple misorderings, and so that's okay. The other thing is that, look, on 6 meters is not very far from the start of the transect, and you'll notice there's nothing in it. Either that was at 6 meters and it was on bare sand, or it was at 66 meters and it just happened to show up on a trail or something like that where there's bare sand. I don't know. I have no basis for rejecting this quadrat, this data entry, so I'm going to keep with it. Okay, so the first part, just scan over data, look for any problems. You know what? You might actually come through here and see a number that's like 100 or 10 or 11, and that would be wrong because the numbers can only go from 0 to, I think, 9 or 10. I don't think we have any 10s in here. Okay, so that's the first part. The second part, I'm helping you out here a little bit because remember, these numbers are cover classes. But in our calculation of the Shannon-Weaver diversity index, we need a percent cover and proportion of percent cover. And so not median cover class. So not cover class. So what we need to do is convert these cover classes back into the percentages. What is the relationship between 1 and percent cover, or 2 and percent cover? That was given to you, but it's kind of buried in the very end of the handout on the dune not the dune analysis, the dune field trip that you would have gone on, and the methods for that you followed for doing this. And so instead of sending you on that Easter egg hunt to find that information, I have just put it over here. You could find it. I think I did. I gave it to you. Well, hopefully you have it. Here are the numbers. I just copied them and pasted them here. Remember, guys, you're trained to receive magical Excel files from your teacher and everything's in there. But once you have an Excel file, it's yours to do with what you want. And so you should customize it and make it work for you. What I've done is I need to convert these cover classes to median percent. I need to do some calculation over here. So I'm just doing it off to the side. I copy and paste and I'm doing some operation here. All right, so I want to lead you through this. Turns out that a cover class of 2 equals between 2 and 10%. We can't use a range of from 2 to 10%. What we decided to use is the median, the halfway point between 2 and 10. And you could do it on your fingers, 2, 3, 4, 5, 6, 7, 8, 9, 10. What's the middle number here? I don't know. I guess it's 6. Because instead of counting on my fingers, I use this nifty command in Excel, equals median to 10. And for 11 to 10 equals median 11 to 20, equals median 21 to 35, and so forth. So I'm actually just checking right now, making sure I did these right, because previously I did them wrong. Okay, these look pretty good. Great. I think. Yeah. Okay, looks good. Okay. All right, so now these are the magic numbers, and I need to convert in here all these cover classes to this number right here. And so, wow, that could be a real pain in the butt. And yes, actually, massaging data to get what you want is a pain in the butt. As you'll find as you go through this Excel exercise, there's a lot of just kind of boring, repetitive work, difficult. I don't know. It's not beautiful work. It's just messing with Excel. And I just wanted to say one global thing about that. Remember, you are after a nugget of beautiful truth. You have come up with a hypothesis and a method, and you've collected data, and you're crunching the data. In the end, there's this shining goal at the end that you can get a conclusion and evaluate your hypothesis. Getting to that point is sometimes difficult and requires just boring, repetitive work, and that is a part of the scientific method. So I'm just saying. Okay, so be patient. So, and have faith that that nugget of truth will be so beautiful, it will have made it all worthwhile. Okay, so let me just, okay. These things here are all equations, and sometimes I get a little bit nervous about, in a moment I'm going to be using cell references to this guy right here. And I might not, but I would just rather have the values. So I'm going to copy this stuff and I'm going to paste as values, and that's just me being nervous. And by the way, I'm done here, but I see this blinking line here. You can get really messed up if you start clicking anywhere with that blinking line there. Hit escape to get rid of it. Escape. Okay, so I'm no longer copying and pasting. And these are the values that are associated with the median percent cover of all these guys. All right, directions say use the replace function to replace all the 9s with 98, and then the 8s with 88, and 7s with 73. And so that's what I'm going to show you how to do. I guess I'm going to do it maybe twice and then stop, and we'll be done with this video, and then I'll start a new one. I just want to show you how to do this replace thing. So the find and selecting is here, but before I do that, what I want to do is select all my data to tell Excel what I want it to be looking for. So I'm going to make this really small so I can more easily select all my data. I'm going to go here, Abronia latifolia to wild strawberry, and all the way to 70, all the way to the end, right here. You'll notice that we have frozen the top row and the first column, so that as we scroll around, we always see those, and that's really helpful. Okay, so that's the stuff I want to do the find and replace on. So I'm ready to go. I click over find and select here and click replace. And before I do any finding and replacing, I want to open up this options here to make sure I tell Excel exactly what I want it to do. I want it to match the entire cell contents. So which I mean is, so if I want you to, I want it to find a 9 and replace with something. I'm actually going to replace it with a 98. If Excel comes upon 19, which it won't, but if it did, I want it to ignore that because I don't want 19 replaced with, well, the 9 in 19 replaced with 98 to give me 198. I want it to find the entire cell contents that are just 9. So that's important to do, or you'll get really screwed up stuff. So I'm feeling lucky. If I'm not feeling lucky, I'll just do 1. Oops. What? Well, I don't know. So I did replace all, and that worked. I made 10 replacements, and I think that's about right. So now I'm going to replace an 8 with over there it's an 88. I'm actually not using a cell reference because I don't want to. 88. Could I replace with? No. So now I've unselected everything, so that's bad. So I'm going to put this aside and redo this. Go back to the beginning. Abroni latifolia, wild strawberry, gets the end of my data, which is here. Boom. Okay, do that. I want 8 replaced with an 88. No fooling around with cell references here. Okay, fine. And replace all. And did 8. And just keep doing that until you get to 1. And you are done. And by the way, go in and look in your data, and you can see that, in fact, some replacements have been made. So that's great. Okay, that's all for now. We're getting to the more interesting thing next.